Hey everyone, Chang here. This is the skill building video series. For today's topic, we're going to talk about the quadratic formula. Now, this is one of the more common formulas that students usually memorize. There's even songs and poetry written to help students memorize this particular formula. For those of you guys who have forgotten it, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, the ABC actually comes from the standard form of a quadratic equation. A is whatever's in front of the x squared. So it's ax squared plus b, what's in front of the x, which is b, and then plus c, that's our c. So every time we're trying to use the quadratic formula, we look at the quadratic equation and then we start plugging in the a, b, and c and then solve for that. Now, first and foremost, what does the quadratic formula do? It actually does only one thing. It helps you figure out the x-intercept of a quadratic equation. Now, here's the thing. I'm going to break down parts of the quadratic formula because guess what? Even though it only does one thing, it only finds the x-intercept, there's actually components of it that tells us a lot. Now, here's the thing. The key is the plus or minus and the b squared minus 4ac. Not the square root, but the inside of the square root. I'm going to just put a little like marking right here just so you guys can see it. B squared minus 4ac. That's one of the key components of this formula. The other one is the plus minus. Now, here's the thing. There's a reason these two are the key components. X-intercepts, there's three possibilities when we're graphing a parabola or a quadratic equation. There's one where it actually intersects, and that's the most common one, where it intersects the x-axis twice, right? It doesn't always have to be negative and positive, it just intersects it twice, right? That's the most common one. But there are two others. There's one where it intersects it one time, and the way it does that is that it actually just touches it. And that point right there is usually the vertex, right? The vertex touches the x-intercept, so every other point afterwards doesn't touch it. So it intersects only once. The other one, you can sort of guess, is one where it basically doesn't touch at all. So there's three scenarios. This in itself can actually tell us how many x-intercepts there are. Not just what they are, but how many. Now, how does it work? The plus and minus is the key because the plus and minus allows two situations. The same thing with only the plus, so it's going to be negative b plus square root b squared minus 4ac all over 2a, and then negative b minus square root of b squared minus 4ac all over 2a. That gives us the two situations, one x-intercept and another one. One for the plus and one for the minus. Now, how do we get to a situation where there's only one x-intercept? Well, guess what? The only time the plus and minus actually doesn't matter is if this in here, which is known as the determinant, this whole thing becomes 0. Because guess what? If you add 0, doesn't matter. If you subtract 0, doesn't matter, right? It doesn't change the number at all. So if this whole thing, this determinant right here is 0, then guess what? There's only one x-intercept, and that's a situation that looks like this. Now, the last one, where there's no x-intercept, how does this tells us that? Especially since it's meant to find x-intercept. Once again, it's the determinant. Keep in mind that's inside a square root. The one thing at this moment that you can't do with a square root is to take a square root of a negative number. There's that whole imaginary number and all that stuff, but at this moment, there's really not, right? You can't take a square root of a negative number. It just doesn't make sense. It's undefined. And hence, this whole formula doesn't work. And when you know this whole formula doesn't work, then you have a situation like this where you have no x-intercept. So let's practice. So for our first problem we have here, y equals x squared plus 3x plus 2. Now, every time you see just an x squared without a number in front, there's technically a number, it's just invisible. Usually, if it makes it better, you can just put one right there, it's an invisible one. So, our a is actually right here, our b is right here, and our c is right here, right? A, B, C. Okay, now we can plug it into the quadratic formula. So, negative b, this is our b, so it's going to be negative 3 plus or minus the square root of b squared, so it's going to be 3 squared minus 4 times a, which is our invisible 1, so it's going to be 1, and c, which is our 2. this whole thing is going to be divided by 2 times a, which is our invisible 1. There it is. Simple as that, right? Now, before anything, at this point, you already sort of know how the graph is like. How many x-intercepts are there? Well, if we look at the inside, 3 squared, let's just write it up here, 3 squared minus 4 times 1 times 2. That's just 9 minus 8, which is 1. Okay, so this whole thing in here is just 1, right? It's not 0. It's not some crazy negative number. So in that case, there's actually 2 x-intercepts. So let's just plug it in and see what happens. Rather than this whole thing now, it's going to be negative 3 plus or minus the square root, and we figured out it's just 1. All over 2 times 1 is just 2. So where does this have 2 x-intercept? The plus and minus, right? You have two situations. Negative 3 plus square root of 1 is just 1. So it's going to be 1 over 2. And the other situation is negative 3 minus 1 over 2. Once we solve that, negative 3 plus 1 is negative 2. Negative 2 over 2 is negative 1. So it's going to be negative 1 is one of them. Negative 3 minus 1 is going to be negative 4. Negative 4 divided by 2, well, it's negative 2. So in this case, these are our 2 x-intercept. All right, let's look at another one. Y equals x squared plus 6x plus 9. Now, once again, no number, technically an invisible 1. So we can just put it right there so we know this is our A, this is our B, this is our C. Simple as that. Then we plug it in. Now, we have our negative b, which is going to be 6, negative 6 in this case. Negative 6 plus or minus the square root of 6 squared, because that's b, right? Minus 4 times a is 1, and c is 9. All over 2 times a, which is 1. Okay, now, once again, before anything, we can actually look at the determinant and try to figure out what the behavior is like. How many x-intercept are in this quadratic equation? Well, in here, basically 6 squared is what? 36 minus 4 times 1 times 9, which is actually 36 as well. So 36 minus 36, 0. Simple as that. Well, if that's the case, if inside is 0, square root of 0 is 0, you're going to be adding a 0 or subtracting a 0. Doesn't matter if you add it or subtract it. They're still going to be the same number. So in that case, there's only 1 x-intercept. So just from that alone, we know that this formula or this equation right here only has 1 x-intercept. And of course, we can figure out what that is. Well, in this case, let's just solve it. We have negative 6 plus or minus the square root, and we figured out it's 0. All over 2 times 1 is just 2. All right, so it's going to be 2. Well, that's the same as negative 6 plus or minus square root of 0, 0, all over 2. Well, if you plus 0, doesn't matter. Subtract 0, doesn't matter. So this thing is just technically just negative 6 over 2, which if you simplify it, is negative 3. So for this quadratic equation, there's only 1 x-intercept, and it's negative 3. All right, let's try one more. We have y equals x squared plus 4x plus 5. Once again, there's going to be an invisible 1. And of course, you're not always going to see a situation where it's going to be an invisible 1. There's going to be other ones as well, which you can plug in. Still the same concept. But in this case, it's going to be an invisible 1. This is our A. This is our B, which is in front of the x. And this is our C. All right. Now, we just plug it in. Negative 4 plus or minus the square root of 4 squared minus 4 times a, which is 1, times c, which is 5, all over 2 times a, which is 1. Okay? Now, once again, before anything, if we want to truly understand this quadratic equation, let's look at the determinant. The determinant in here is just 4 squared, which is 16. Okay? 4 times 4 is 16. And then after that, we're going to be minus 4 times 1 times 5. 4 times 1 is just 4, times 5 is 20. So 16 minus 20. In this case, 16 minus 20 is negative 4. That's a problem, right? Because guess what? That means inside here is negative 4. If we were to rewrite it out, negative 4 plus or minus the square root, and that whole thing inside simplifies to -4. The bottom here is just 2 times 1, which is just 2, right? -4 plus or minus the square root of -4. Now, once again, yes, in the future there's going to be imaginary numbers and we can go crazy with that. But as of right now, you really can't take a square root of -4. It makes no sense. Remember, square root is just basically a number that multiplies itself to be whatever the numbers that's in there. So there's no number that multiplies itself that will give you a -4 in this situation. So this whole thing doesn't work. Well, if this whole thing doesn't work and this formula is meant to find an x-intercept and it doesn't work, guess what? This quadratic equation right here has no x-intercept. It's one of those parabola that never touches the x-axis. Now, for this last problem, let's see if you guys can follow along. Thank you so much for watching this video on quadratic formula and the determinant and how it helps you determine how many x-intercepts are there, if there's any, and what they are. See you in the next video.